Matter is anything that occupies space and has mass. It's composed of atoms, ions, and molecules, which are the building blocks of all physical substances. It can exist in different states or phases, like solid, liquid, and gas. I know that you already know the difference between solid, liquid, and gas. What I'm going to be talking about is what's happening at the molecular level for these three states of matter, helping you understand their chemical definitions and clarifying phase change terminology. More than three states of matter do exist, but I am willing to bet that you spend a lot more time interacting with these three than you do with plasma or Bose-Einstein condensate, so I'm going to skip those. Let's start with solids. At the molecular level in a solid, particles are vibrating in fixed positions. At any temperature above absolute zero, they have some amount of kinetic energy. Kinetic energy is the energy that gives them movement, so they are moving. But the attractive forces between particles, the forces holding them together, are strong enough that they can't break free of each other. They can't slide past each other. The most they can do is vibrate in place. Because of this, solid substances have a fixed shape and a fixed volume. By fixed, I mean that they don't change. A fixed shape means that it's rigid. Of course, you can chip a piece off to break it, but you can't just squish it to make it change shape, because that would require particles to slide past each other. Fixed volume means that you can't compress it and it doesn't expand. Volume is the amount of space an object occupies. If something has fixed volume, that means it always takes up the same amount of space. The particles are already pretty close to each other. They can't really get any closer under anything considered conditions that you'd typically encounter. In a chemical formula, we can specify that something is a solid with a lowercase s in parentheses after the formula, usually italicized if it's type. So this water, H2O, is a solid because there's a little s there. If we add more kinetic energy by increasing the temperature, the particles move more. If there's enough kinetic energy, their movement starts to put up a fight against those attractive forces. Then the particles can slide past each other. We've just melted the solid into a liquid. If we reduce the temperature again, they can once again freeze into a solid. But let's talk about liquids now. At the molecular level in a liquid, particles are still pretty close to each other because the particles are still attracted to each other. But now the kinetic energy, that energy that gives them movement, is strong enough that it's putting up a fight against those attractive forces. The particles are free enough from each other that they can slide past each other. Liquid substances have an undefined shape and a fixed volume. Undefined shape means that they take the shape of whatever container they're in. They can be poured from one container to another. Their shape can change relatively easily, but like solids, they still have a fixed volume, so they take up the same amount of space regardless of what container they're in. In a chemical formula, we can specify that something is a liquid with an italicized lowercase l in parentheses after the formula. So this water is a liquid. If we again add more kinetic energy by increasing the temperature, the particles move even more. If there's enough kinetic energy, their movement can overpower the attractive forces completely. The particles don't just slide past each other, but they break free of each other. We've just vaporized or boiled that liquid into a gas. If we reduce the temperature, they can once again condense into a liquid. In the gas phase, particles have so much kinetic energy that they are moving around wildly. They're not just sliding past each other, they are bouncing off of everything and each other, trying to get as far apart from each other as they possibly can. Gas substances have undefined shape and undefined volume. Undefined shape means that they match the shape of whatever container they're in. Undefined volume means that they expand to fill whatever container they're in. It also means that they can be compressed to take up less space. In a chemical formula, we can specify that something is a gas with an italicized lowercase g in parentheses. So this water is a gas. It's steam. It is possible to transition directly between gas and solid, completely skipping the liquid phase. The transition from solid to gas is called sublimation, where the reverse from gas to solid is called deposition. The most common example would be dry ice, which is the common name for solid carbon dioxide. As an adult, I've only ever seen dry ice handled cautiously in a lab, but I grew up in the 80s, so my grandma definitely brought over for me to play with as a kid. Every once in a blue moon, on a really hot summer day, my grandma would buy an ice cream cake that was packaged in dry ice and bring it over to share. Dry ice was used to keep the ice cream cake cold, specifically because it skips the liquid phase. When it's heated, it does not melt into a liquid and then boil into a gas, not even briefly. It sublimates directly from solid to gas when the temperature hits a balmy negative 78.5 degrees Celsius. Because it skips the liquid phase, the cake doesn't get wet. Your ice cream cake can stay frozen and dry. Side effects may include tissue damage from touching the dry ice or suffocation from carbon dioxide displacing the oxygen in a closed environment, conditions for which would have been perfect in my grandma's car. Next up, mass versus weight. I'm not sure if you'll be laughing with me or at me, but I promise that the difference between mass and weight will be forever seared into your memory. If you have any questions, feel free to leave a comment down below. Thanks for watching Chemistry in a Nutshell. If you feel that I've earned it, please like this video and subscribe to my channel.